Good morning, class. Today, our topic is going to be scatter plots and trend lines. And the extension of that topic will be correlation, correlation coefficient, lines of fit, and we are going to use the lines of fit to make predictions. So what's our goal today? Our goal is to be able to meet the state standards, to represent data on two quantitative variables on a scatter plot and describe how the variables are related. And we're also going to use trend lines to fit the data. That's going to be our goals today. Now, scatter plots, I know, is something we are all familiar with. But the problem that I've seen that students have is determining which quantitative variable to place on the x-axis and which variable to place on the y-axis. And so I'm going to use two concrete examples to explain this a little bit, to determine which is the independent variable and which variable is the dependent variable. All right? The essential question for today is related to the goal, and it's going to be, how can you decide whether a correlation exists between paired numerical data, and if so, what is the line of fit for that data? Now, last week, we talked about histograms. What again did we talk about last week? Histograms.
Pie graph.
Pie graph.
Scatter plot.
A little bit of scatter plot. Stem and leaf plot. I think we talked about that too. And we also talk about the box and what? Whisker plot. But today, our focus is going to be on scatter plot, all right? So we are going to start that with two concrete examples. Now here we have a table given, and it shows the number of miles traveled and the amount of gasoline used, and we are being asked to draw a scatter plot for the data. Now again, we all know what a scatter plot is, but like I said, the difficulty is in determining which of these variables go to the x-axis and which goes to the y-axis. Now, the first thing we have to do in drawing this is to draw the x and y coordinate. All right. So the first thing we have to do is draw the x, and the y coordinate. All right, because all graphs are drawn on the coordinate plane. Next, we have to label the x-axis and the y-axis. Now we have two variables. We know that the independent variable always is labeled on the x-axis, and the dependent variable is always labeled on the y-axis. By looking at these two variables, do you think the amount of gasoline used depends on the number of miles traveled, or the number of miles traveled depends on the amount of gasoline used? Which is which?
The miles traveled depends on the gasoline.
That's correct. The amount of gasoline used depends on the amount of miles traveled. So therefore, the amount of miles becomes an independent variable, and it's labeled right on the x-axis. So we have here number of miles, and the amount of gasoline, which is dependent on the number of miles, is labeled here, gasoline used. Now, the next step is to choose appropriate scales so that the data values all fit on the graph. And again, this is an area where many students have a problem. Now let's look at the number of miles traveled first. We see that they range from 15 to 75. All these numbers are in the tens, right? And so therefore, the appropriate unit to choose will be a scale of 1 unit to 10. Now if we decide to choose a scale of 1 unit to 1, we are going to make 75 tick marks. That's a lot to do, right? So, but if we choose a scale of 10, 1 unit to 10, that simplifies things a little bit. So, on the x-axis, we are going to have start from 0. We're going to have 10, 20, 30, 40, 50, 60, 70, and so on up to 100. Now, once we finish with that, our next step is to choose a suitable scale for the amount of gasoline used. Now we see that all these numbers are in the units, And so that makes it very easy. So therefore we're going to just choose a scale of 1 unit to represent 1 gallon of gas. So here we have 1, 2, 3, 4, 5. Okay. Once we're done with these two, the next thing we have to do is to plot the point on the coordinate plane. Now I've already got the points plotted here, so I'm just going to hang it here, and this is what we have. And so this gives us the scatter plot. So this is the scatter plot we have. Now, what do we see about the scatter plot here? Can somebody tell me the trend that is in the scatter plot?
It's linear.
We see that the scatter plots are all lined up, all right? And if we draw a line through the point, we see that the line passes through all the points, right? And that's the points are rising from left to right. Also, we can see that from the table as well. We see that as the number of miles traveled increases, the amount of gasoline used also what? Increases. So there seems to be a relationship between the amount of gasoline used and the number of what? Miles traveled. We call this relationship, we call it a correlation. So this is called correlation. All right? The relationship between the two variables, the miles traveled and the gasoline used, we call it a correlation. Now, as somebody said, it's increasing from left to right. So therefore, we call this kind of correlation a positive correlation. A positive correlation. There appears to be a direct relationship between the miles traveled and the gasoline used. In fact, we can say that the relationship is perfect. It's a perfect relationship. There is a 100% relationship, or if you want, correlation between the miles traveled and what? And the amount of gasoline used. So 100% correlation. And we said, when it's 100% correlation, we call it what? A perfect correlation. Perfect. Now, 100% simplified equals 1 whole, right? So we can say that 1 equals what we call correlation coefficient. So 1 is what we call a correlation coefficient between the miles traveled and the amount of gasoline used. Okay? So how can we define correlation coefficient? Can somebody define correlation coefficient for me here now? In your own words, how can you define correlation coefficient? We can say that it's a number that measures the strength of the correlation between two quantitative variables, right? It measures the strength of the correlation between the number of miles traveled and the amount of gasoline used. It's a number, all right? Now, so this is one example. Now, let's go to a second example. All right, here, again in this graph here, we have scatter plot, all right? And we see that again, it shows the same trend as the previous one. The points are all rising from left to right. So we can conclude that, again, this correlation is a perfect correlation. And can somebody tell me what you think the coefficient of, the correlation coefficient is going to be?
1.
It's going to be a 1, all right? The coefficient of correlation is going to be a 1. All right, now we have our second example. In this example, we have high temperatures, all right, and the number of lemonades sold. And we are being required to draw a scatter plot of this information. Just like the previous one, it's going to be the same thing. It's going to be presented on the coordinate plane, all right? And then we are going to make a determination as to what is the dependent variable and what is the independent variable. All right, that's the first thing we've got to do. So here we have high temperatures, we have the number of lemonade sold. I would say that the number of lemonade sold is dependent on the high temperatures. From the table, we are seeing that trend. Probably as it gets hotter, people tend to buy what? More lemonades to cool themselves. So this here depends on the high temperature. So therefore, we can say the high temperatures is what? Independent variable, and it's going to be labeled on the x-axis. So here we have high temperatures, high temps, and the number of lemonades sold will be the dependent variable, and here we have lemonades. So once we label the two axes, the next thing for us to do is to choose an appropriate scale. Again, here we see that the numbers range from 25 to 92. So an appropriate scale, will somebody tell me, are we going to use in increments of 1, increments of 5, increments of 10? What do you think is the most appropriate for us to use?
10.
Increments of 10 will be most appropriate for us to use, okay? So this will be what? The high temperatures will be 10, 20, 30, 40, 50, 60, and so on. And for the number of lemonades, again, we have from 43 being the smallest value we have here, right? And then we have 80. What scale do you think is most appropriate for us to choose? Are we going to go in increments of 1, increments of 5, increments of 10?
10.
Again, we have to use increments of 10. So here we're going to have 10, this will be 0, of course, 20, 30, 40, 50, and so on. And if we plot, if we draw the scatter plot, this is what we're going to have. I thought I had something here. Is it gone? Okay. So this is what we have. Alright, so this is scatter plot we have. High temperatures against lemonade sold. What do we see about the scatter plot in this very graph here? It appears linear, okay, so this one too we can say there is a positive correlation going on between the high temperatures and the lemonade sold. But is it perfect?
No,
It's not perfect, right? Why do we say it's not perfect?
it doesn't touch.
Because they are not all lined up, all right, on this line here drawn, all right? This line is what we call a trend line. It is a line drawn so that we have about half the number of points above it as we have below it, okay? And so this here is not a perfect relationship. However, the correlation between the two variables is still very strong. I would say it's about what? Giving it a numerical value, we can say it's about what percent? 90%. I say it has a strength, the correlation has a strength of about what? 90%, all right? So we can say that the correlation coefficient is
90%.
90%, and as a decimal, the correlation coefficient is
0.9.
0.9, all right? So the correlation coefficient is 0.9, all right? And it's positive, and it's 0.9, all right? These are more samples of scatter plots. All right, let's take a look at the one on the right first. Here we have beach goers. We see that the independent variable is the average daily temperature, and the dependent variable is the number of visitors. And what trend do we see? It appears that as the daily temperatures increase, all right, the number of people visiting the beach visitors also what? Increase. So there appears to be some relationship or a correlation between temperature and the number of visitors to the beach. Again, we can describe this as positive because it's rising from left to right, right? But what is the strength of that correlation? We know that it's not a perfect correlation, right? Because if we draw a trend line from the origin passing through, and we know that the trend line is a line drawn so that we have an equal number of what points above as we have below it. we have some of the points kind of dispersed a little bit from the trend line, right? Yet still, there's still a fairly strong correlation between temperatures and what? And the number of visitors to the beach. If we want to assign a numerical value, probably we could say it's about, somebody give me assign a number to that value. Would you say it's about 80%?
Yeah.
Yeah, we will say it's about 80% strength of that relationship, right? And so if it's 80%, then we shall say that the correlation coefficient is point what? 0.8 is 0.8. So again, this is an example of a positive correlation. Now here, what do we notice about the dots in the scatter plot?
They're everywhere.
They are everywhere. They are rising though. They are rising, so we know it's a positive correlation. But they are everywhere. And so we know that the strength of that correlation is pretty weak, right? So we say that this has a low positive correlation. So far, what the examples I've given you are about what? Positive correlation. Now let's see examples of negative correlation. All right. So here in this example here, this here will be your independent variable, and this will be your dependent variable, even though they've not been labeled, right? We say that there's a perfect correlation going on, right? But in the what? In the inverse direction. Here we see that as the independent variable is increasing, the dependent variable is what? Decreasing. This is an inverse relationship. It's inverse correlation. It is perfect though. It is perfect because we see that the dots have all been what? Line up. It's 100% correlation between the independent variable and what? And the dependent variable. Now, if the perfect positive correlation was 1, then what do you think the perfect negative correlation coefficient will be?
1.
We said for the perfect positive correlation, the correlation coefficient was what? 100%, 1. But this is a perfect negative correlation. So what do you think the correlation coefficient will be?
0.
No.
Maybe 1.
Negative 1. So the correlation coefficient of this is what? Negative 1. So for the perfect negative correlation, the correlation coefficient is negative 1. For the perfect positive correlation, the correlation coefficient is what? Positive 1. Now, let's see this one here. What sort of correlation is it? Is it positive or negative?
Negative.
It's negative. Is it perfect? No. I see you shaking your head. No, it's not perfect. Why? It's because all the points are not lined up on an imaginary trend line, right? So we know that it's not perfect. However, the relationship is still pretty strong. The correlation is still what? Pretty strong. And assigning a numerical value, we can say that this is about 90. That's correct. It's about 90% correlation between the two variables, all right? But it's in the reverse direction, and so therefore the correlation coefficient will be what? Negative 0.9. Negative 0.9, all right? So far we have discussed what? Correlations, negative correlations, and positive correlations. We know what a trend line is, all right? If a line drops from here through, is what we call a trend line. We know what a scatter plot is. Now, in our next topic, we are going to see how we can determine the line of better fit and use that trend line to make predictions. So in this table, we have been given X and Y values, and this here is the scatter plot of the information we have in the data. All right, 2 lines of fit for this data are Y equals 2x plus 2 and Y equals x plus 4. So, which of these lines here is a better fit for this graph?
The red one.
The red one appears to be a better fit for the graph because we see that we have 2 points above it and we have what? 2 points below it. So even without using any other more precise methods, we can see just through eyeballing, right, that the red one is a better fit for the graph. And so that is one process by which we can determine which of these two is a better fit by using eyeballing. But there is yet a more precise method to do it, and this method is called finding the sum of the residuals. It's called the sum of the squares of the residual. This is what we use to make a more accurate determination, all right, which is much better than just eyeballing, all right. And so what is a residual? A residual is just, for instance, these are the points, all right, these are the points on the scatter plot, and these are the two lines given. The residual is just the distance from the point to the line, all right? So from the point to the line is what is called the residual. From the point to the line is what is called the residual. From this point to the red line is what is called the residual. From the point to the red line is what is called the residual. So from each point to each line is what is called what? The residual. So now, what we do is we make a table of it. So first, let's write down the coordinates of the point. So the coordinates of the point, we have x and y. So when x is 1, y is what? 7. For the second point, when x is 2, y is what? 5. For the third point, when x is 3, y is what? 6. And for the fourth point, when x is 4, y is what? 9. All right? Now, for the red line, which of these equations do you think is the equation of the red line? Do you think it's 2x, y equals 2x plus 2, or y equals x plus 4?
Y equals x plus 4.
Is y equals x plus 4 because the y-intercept is 4, we see it is 4 right here, right? So we have what? X plus 4 equals y. Now, when x is 1, what is the value? What does the red line predict? 5. And when x is 2, the red line predicts what? 6. And when x is 3, the red line predicts what? 7. And when x is 4, the red line predicts what? 8.